Hello, today we will be covering 2.3 conditional statements. You'll notice we do have a first warm-up slide. Because we are skipping 2.2 this year, we don't know how to do this, so you can just cross that out and go down to our lesson objectives. Our major objectives here are you guys will be able to analyze statements in if-then form and write the converse, inverse, and contrapositives of a conditional statement. So our new vocab is conditional statement, if-then statement, hypothesis, conclusion, related conditionals, converse, inverse, contrapositive, and logically equivalent. So our key concept here is conditional statement. A conditional statement is a statement in if-then format, and you can write this in symbols, P then Q, and this is read if P then Q, or P implies Q. I'll keep saying it if P then Q. So the hypothesis of our statement is the phrase that immediately follows the word if. So the phrase that follows the word if, that would be our P. And then the conclusion of a conditional statement is the phrase that immediately follows the word then. That's Q. If P, then Q. So let's try it out. Identify the hypothesis and conclusion of the following statement. The statement is if a polygon has 6 sides, then it is a hexagon. So the hypothesis here is what follows the if statement. You can either rewrite it or just write an arrow. That is, a polygon has 6 sides. And the conclusion is it is a hexagon. Notice I'm not including the word if and I'm not including the word then. It is what follows them. So a polygon has 6 sides is the hypothesis. And the conclusion is it is a hexagon. Once again, we are going to identify the hypothesis and the conclusion. Now notice the if statement doesn't necessarily come first in our sentence, but it is still going to be our hypothesis. So this says Tamika will advance to the next level of play if she completes the maze in her computer game. So our hypothesis is she completes the maze in her computer game. And then if you think about games, if you complete something, then you will probably head to the next level. So then Tamika will advance to the next level of play is the conclusion. Now there isn't even the word then there. You just have to infer that because the hypothesis has happened, the conclusion moving to the next level will happen as well. Okay? Now we have a multiple choice one. Which of the following choices correctly identifies the hypothesis and conclusion? So it's pretty easy. If you are a baby, then you will cry. So you are a baby is the hypothesis. You will cry is the conclusion. So part B. Another one here. Identify the hypothesis and conclusion, then write the statement in if-then form. Now, I actually prefer to write my statement in if-then form before stating my hypothesis and conclusion. You can do it either way, but I find it easier to do it that way. So my if-then form, I'm going to do it backwards, is if a student is in 12th grade, then they are a senior. Or I can say, if students are in 12th grade, then they are seniors. Or if you are in 12th grade, then you are a senior. You can write it a variety of different ways. I'm going to say, actually, if students be careful here. You wouldn't want to say if a student is a senior, then they are in 12th grade. Or you wouldn't want to say if a person is a senior, rather, then they are in 12th grade. Because senior can also refer to a senior in college who would not be in 12th grade. Or an elder person who is not in 12th grade either. So we're going to write it in this if-then form. If students are in 12th grade, then they are seniors. So our hypothesis here, I'll just copy it up. The hypothesis follows the if statement. And the conclusion follows the then statement. Hopefully you're able to follow along so far. That is our hypothesis and conclusion. And we have one more here. Which of the following is incorrect if-then form of the given statement? Two of these are both true statements, but one of them is a better writing of this, and that would be B, because it's most similar to the one we were already given, and it is if a polygon has 8 sides, then it is an octagon. Technically, C says something very similar, but it's not quite written the same. All right, so a conditional statement is true if whenever the hypothesis is true, the conclusion is also true. So determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. So if you subtract a positive number from another positive number, the result is a positive number. Now we only need one counterexample to prove this false, and there is a multitude of counterexamples. It says if you subtract a positive number from another positive number, so let's say 8 minus 12, it should be another positive number based on this. But in this case, it is not. So this is our counterexample to this conditional statement. Then we are going to determine the truth value of this conditional statement. If true, explain your reasoning. If false, give a counterexample. The conditional is, if last month was February, then this month is March. I would say that is true, because March follows February. As we go through the months of the year. Okay? Now we have something else here. This is another idea. So we have our original conditional statement. That's our P then Q. This is in the form if P then Q. I like, instead of using this geometry example on the side, to use the example if it is raining, then I have an umbrella. Might be a little easier to hear the difference, okay? So the converse statement, you'll notice we've switched P and Q's location from the original. The converse is formed by exchanging the hypothesis and conclusion of the original, conditional. Okay? So the if and then stay, but what follows switches. So it would become, if I have an umbrella, then it is raining. That would be my converse. My inverse is formed by negating. Now it'd be good to note that the squiggly line means not, or the negative, okay? Both the hypothesis and conclusion of our original conditional. So it's based off the conditional. So this one would become, if it is not raining, then I do not have an umbrella. And then the contrapositive is formed by negating both the hypothesis and the conclusion of the converse of the conditional. So the contrapositive is similar to the converse, but negated. So it would become, if I do not have an umbrella, then it is not raining. Okay? So we'll try a few so you can see them out. Write the converse, inverse, and contrapositive of the following true statement. So we know this is true. Determine the truth value of each statement. So we have to write true or false. Truth value just means true or false. And if a statement is false, give a counterexample. So if it rains, the baseball game will get canceled. So our converse is just flipping the two. Maybe it'd be helpful to add the word then in here so we can see that. So our converse of this is if the baseball game is canceled, then it is raining. Now we're assuming this is like thunderstorms, not just a little sprinkle. But that would be our converse here. Now, I do want to point out, I don't mind so much the tenses you use, and you can even add words here and there if you need to. So I have it in the is form. You could say if the baseball game was canceled, then it was raining. I don't mind so much. Okay? Now I need you to decide the truth value. So is it true or false? So if the baseball game is canceled, then it is raining. So, is rain the only reason a baseball game could get canceled? I would say no. We learned last year baseball could get canceled for COVID. It could get canceled because the other team couldn't make it. It could get canceled for another sort of weather-related thing. So I would say this is false. The game could get canceled for a variety of reasons. Okay. And then the inverse is like our original, but the negation of it. So it's like the original, but if it is not raining, then the baseball game will not get canceled. Now, once again, I would say this is the same truth value as the last one for the same reason even. So I'm going to draw some arrows so they both are the same truth value and reason. And lastly, our contrapositive is similar to our converse, except we negate it. So, if the baseball game is not canceled, then it is not raining. So if we are playing, then it is not raining. I would say that is true. Okay? So that's our converse, inverse, and contrapositives. I would say today's information is more English-based than even math-based today. We're just learning our new vocab terms and how we can use them. Now, I do want to take a look at this logically equivalent statements. Notice, our conditional, which is this guy here, and our contrapositive have the same truth value. That will happen all the time. They are logically equivalent. That means they have the same truth value. And our converse and inverse will always have the same truth value as well. So, if you know your conditional is true and your contrapositive then your contrapositive must also be true. If you know your inverse is false, you know your converse must also be false. Now, they could all be true, they could all be false, but you know those have to be pairs. They are logically equivalent. So we are now going to write the converse, inverse, and contrapositive of this true statement. So we know this guy's already true, which means we know already that the contrapositive is true. And then determine the truth value of each statement. If a statement is false, give a counterexample, okay? So I'm going to actually start by writing my conditional as an if-then statement. That'll make it easier for me. And then we'll go from there. So I'm going to say, if angles measure 90 degrees, then they are right angles. Okay? So our converse leaves our if and then words where they are, but switches what follows them. So if, I'm going to be a little picky because they refers to angles. I'm going to leave angles here. So if angles, so that way we know what we're talking about earlier. If angles are right angles, then they measure 90 degrees. So if we have angles that are right angles, they will be 90 degrees. So this guy is also true. So we can have them all be true since the converse is true. We know the inverse must be true. Let's go ahead and write the inverse. So the inverse is just the negation of the original conditional. So if angles don't measure 90 degrees, then they are not right angles. Okay? So if they're not 90 degrees, then they are not right angles. That is a true statement there. And our contrapositive is the negation of our converse. So we're negating this guy here, our converse statement. So we have, if angles are not right angles, then they are not 90 degrees, or they do not measure 90 degrees. All right? So we have something called a biconditional statement. You'll see that on the back side of your worksheet. There is book homework and a worksheet tonight. You'll see biconditional. We haven't covered that yet. So let's look at it here. Biconditional is when both the conditional and the converse are true. So we can write a biconditional statement. I've touched on this before when we were talking about some theorems and postulates on how we had a biconditional statement, but we didn't really know what that was. So today is the day that we learn. So because on this last example, both our conditional and our converse was true, we can write a biconditional statement. I could call these if and only if statements. So if they are both true, conditional and converse, we can write a biconditional statement, and that would look something like angles measure 90 degrees if and only if they are right angles. Okay? This tells us when we have a biconditional statement that both the conditional and the converse are true, and we can read them off as they are up here. If angles measure 90, then they are right angles, and if angles are right angles, then they measure 90 degrees. So the biconditional tells us both of those things, but in one sentence instead of two. All right. Hopefully you can get done with the 2.3 stuff. If you have any questions, you can email me. Have a great afternoon.